So think about this for a second. Every single time you hit enter on a prompt in a tool like ChatGPT, there is this massive, completely unseen meter that just starts running.
Oh, yeah. And it is running fast.
Right, like incredibly fast. Because right now, up to maybe 90% of the operational cost of artificial intelligence has absolutely nothing to do with actually making the AI smarter.
No, not at all. It's just the brute force cost of, getting it to generate that specific answer for you in that exact moment.
Exactly. And today, we're doing a deep dive into the literal piece of silicon that was designed to just completely shatter that bottleneck.
It's honestly about time, too, because, the underlying economics of the AI industry have been fighting this sort of losing battle against physics for a while now.
Yeah, the current hardware simply wasn't designed for the scale of usage we're seeing today.
Right. It's like trying to power a whole city with a bunch of AA batteries.
Which brings us to the actual mission of today's deep dive.
Ah.
Because on June 24, 2026, OpenAI, working in this massive partnership with Broadcom, unveiled a brand new custom AI chip, codenamed Jalapeño.
Jalapeño, it's a great name.
It is a spicy name.
Yeah.
But to really understand why this piece of hardware is shifting the entire physical foundation of artificial intelligence, we have to clearly separate how AI is built from how it is actually used.
Yeah, that is the crucial distinction.
Right. So specifically, the difference between training an AI and inferencing.
Grasping that distinction is really the only way the whole Jalapeño strategy makes any sense at all.
So let's break that down for everyone listening. Training versus inference.
Okay, so think of AI training like putting a student through the most rigorous, exhaustive university program ever conceived, like ever.
Okay, so reading every book in the library.
Literally feeding the model the entire library of human knowledge. It requires this astronomical amount of computational power running continuously for months on end just to find the patterns in billions and billions of data points.
Right, so the heavy lifting there is just establishing all those neural connections.
Exactly. But inference, which is the moment you actually ask the AI a specific, entirely new question, is an entirely different mechanical process.
Because it's not learning anymore, right?
Right. The AI is no longer learning from scratch. It is taking that massive web of knowledge it already built during the training phase and executing a very specific path through it to generate your answer.
So the heavy lifting is finished.
Yeah, the heavy lifting is completely done. Inference is all about quick, precise execution, and OpenAI is building the Jalapeño chip exclusively for that second part.
Wait, exclusively? So Jalapeño does not train models at all?
It does not train models. It only runs inference, period. Which, that represents a massive strategic pivot away from the general purpose hardware that the whole industry has relied on for, the last decade?
Right, which brings up a huge question for me. I am trying to wrap my head around the sheer scale of the cost problem here.
Mm-hmm.
Why does OpenAI, which is, a company famous for software and research, suddenly need to get its hands dirty manufacturing physical silicon?
Well, if you look at the sources we have, they show that inference now accounts for roughly 80 to 90% of the daily operational costs for large language models in production.
80 to 90%. That is insane.
It is a staggering operational burden. For years, the industry standard has been using general-purpose GPUs to run these models.
And GPUs are incredible, right? Like they catalyzed this entire AI boom in the first place.
Oh, absolutely. They're amazing engines. But every single time a user queries an LLM, the model has to load its massive parameters into memory, compute the probabilities for the next word, and spit it out.
And then you multiply that energy draw by millions of users.
Millions of users querying the system millions of times a second, all over the exact same time. The power consumption and the financial costs just become completely astronomical.
Okay, let's unpack this. I want to use a specific analogy drawn straight from our source material because I think it perfectly illustrates the problem.
That's a really good analogy.
Right. So think of the market-dominating GPUs that the industry has been using as this incredible top-of-the-line all-terrain vehicle.
Like a heavy-duty ATV.
Exactly. It has four-wheel drive, a winch, massive mud tires. It is rugged enough to do absolutely everything, including the incredibly heavy lifting of training an AI model.
Which is like hauling boulders up a mountain.
Right. But if you were just using that massive ATV to commute, like 5 minutes down a perfectly paved highway to pick up groceries.
Which is essentially what inference is.
Exactly. It is wildly inefficient. You are burning massive amounts of gas just dragging around thousands of pounds of heavy equipment you aren't even using for that trip.
Yeah, the overhead of all that versatility is just incredibly expensive.
Which brings us to Jalapeño. If the GPU is the all-terrain vehicle, our sources describe Jalapeño as a master specialist chef.
Right, a highly trained specialist.
Right. This chef does not know how to bake a cake. They don't know how to roast a turkey. They cook one specific dish, inference, but they do it flawlessly, instantaneously, and using a fraction of the energy.
Because they don't have a kitchen cluttered with blenders and mixers they never touch.
Exactly. Every square inch of their workspace is optimized for that one single recipe.
And at OpenAI scale, I mean, switching from the ATV to the specialist chef completely rewrites their entire business model. The initial estimates for analyzing project that Jalapeño is going to cut operational costs by roughly 50%.
50%. But wait, hardware alone doesn't magically make math cheaper, right? I'm trying to understand a 50% cost drop. Is this just about stripping out the unnecessary parts of the chip, or is the actual physical layout fundamentally different?
Oh, the physical layout is entirely different. We really have to look under the hood at the specific architecture here to see why.
Okay, let's get into the weeds a bit.
So Jalapeño is classified as an ASIC. That's an application-specific integrated circuit. And more specifically, it utilizes a domain-specific architecture, or DSA.
Okay, so a standard processor is designed to be versatile. It has to, render video, run word processors, handle web browsing. So an ASIC throws all that versatility out the window. But what does the domain-specific part actually mean in practice?
Well, instead of just hardwiring the chip for one single piece of software, which could become obsolete tomorrow, a domain-specific architecture is optimized for a specific mathematical domain.
So a type of math.
Exactly. In this case, it's the highly specific tensor math and matrix multiplications that large language models rely on. Every microscopic pathway, every logic gate on that chip is spatially arranged to execute those specific calculations with zero wasted movement.
And they were doing this on a chip that is what the industry calls reticle-sized, right?
Yes, reticle-sized, which is huge.
Right, and for those listening, reticle size is basically the absolute physical limit of what can be manufactured right now.
Right, you literally can't print a bigger chip.
Because in semiconductor fabrication, the reticle is the physical mask that acts like a stencil. You shine ultraviolet light through it to print the intricate patterns of the chip onto a silicon wafer.
Right.
So a reticle-sized chip is literally the maximum surface area you can print in a single exposure using current photolithography tools.
It is massive. And a huge, huge portion of that massive physical real estate is dedicated to something called high bandwidth memory, or HBM.
HBM, okay.
And this gets to the core physics of why inference is so expensive on standard hardware.
Because this addresses the data movement bottleneck, right? I mean, the actual calculating part of a processor is usually incredibly fast.
Yeah, the math is fast, but the processor actually spends most of its time just waiting.
Waiting for what?
Waiting for data. In a traditional setup, moving data back and forth between the memory banks and the processor takes significantly more time and consumes exponentially more power than the actual calculation itself.
Okay, so going back to our chef analogy.
Right. Imagine your specialist chef is the fastest chopper in the entire world, but the refrigerator is down the hall on another floor.
Oh, wow. So the chef spends 90% of their energy just walking back and forth carrying ingredients.
Exactly. The compute cores are just idling. They're wasting electricity while they wait for the model weights to arrive from memory.
That sounds incredibly frustrating.
It's wildly inefficient. But Jalapeño solves this by integrating that high bandwidth memory physically adjacent to the processing cores. Sometimes they even stack it vertically.
Oh, so they put the fridge right next to the cutting board.
They're using thousands of parallel microscopic lanes to just flood the processor with data. The chef literally has the ingredients sitting directly on the cutting board.
And by minimizing the physical distance the electrons have to travel, you drastically cut the power required.
Exactly.
That makes total sense. And our sources point to hardware-software co-design studies showing that building an ASIC for a fixed workload like this yields energy efficiency gains of like 2 to 10 times compared to general-purpose GPUs.
2 to 10 times is massive at this scale.
But wait, let me push back on this for a second. If ASICs are yielding a 10x energy improvement, the math seems obvious. Why hasn't the entire tech industry already abandoned general GPUs for these specialized chips.
Ah, well, that's where you run into the fundamental trade-off of hardware engineering, flexibility versus specialization.
Right.
An ASIC is essentially frozen in silicon. It is meticulously optimized for the AI architecture that exists today.
Okay, so if the underlying mathematics of how AI models operate changes in, say, 2 years, if we move away from current transformer models to a completely new paradigm.
Then these highly specialized Jalapeño chips might become incredibly inefficient, or honestly, entirely useless.
Oh, wow, that is a massive financial gamble.
It's a huge gamble. A general-purpose GPU is a safe bet. It might be less efficient, sure, but you know it will successfully run whatever crazy new software architecture you throw at it tomorrow.
So by committing to Jalapeño, OpenAI is signaling immense confidence in their technical roadmap. They genuinely believe the current transformer architecture will be the standard for long enough to justify casting it in solid silicon.
Exactly. They are locking it in.
Okay, here's where it gets really interesting to me. I am fascinated by the timeline here, because custom silicon development is notoriously slow.
Oh, it's a nightmare usually.
Right. It is fraught with delays, bugs, and unbelievably complex engineering hurdles. But our sources show they went from initial design to a functional production chip in just 9 months.
Which is absurd. A traditional timeline for a custom data center chip of this complexity is easily 2 to 3 years. Minimum.
2 to 3 years.
Yeah, so delivering working silicon in 9 months just shatters industry standards.
So how do they pull that off? I mean, you don't just sketch a reticle-sized processor on a whiteboard over the weekend.
No, you don't. And this is the wildest part. They use their own AI models to help design the chip itself.
AI designing hardware for AI.
Exactly, because designing a processor involves routing billions of microscopic transistors. It is an immense spatial optimization problem.
Right, like a massive city grid.
Human engineers usually spend months breaking the chip down into smaller subblocks, trying to figure out the most efficient way to connect everything without creating thermal hotspots or signal delays.
But the AI can just look at the whole board at once.
The AI treats the layout like a massively complex 3D jigsaw puzzle. Instead of a human drawing pathways, the AI uses reinforcement learning.
So it's learning by doing.
Right. It simulates millions of permutations, receiving a mathematical reward for finding shorter wire lengths, less thermal clustering, and faster data pathways.
And it just optimizes the physical layout at a speed human teams simply cannot match.
Not even close. It vastly accelerates the electronic design automation process.
That is mind-blowing. But taking a digital layout, even a perfect one, and turning it into physical reality requires a deeply integrated supply chain.
Oh, absolutely. You need partners.
All right, so OpenAI designed the architecture, dictating exactly what the chip needed to do to run their models flawlessly. But to actually build it, they partnered with Broadcom.
Right. Broadcom handled the physical implementation. They translate that architectural vision into actual silicon.
And they also managed the intricate networking required to connect thousands of these chips together, right?
Yes, networking is huge here. And they oversee the incredibly complex manufacturing production at the foundries.
But you also have a third crucial player in all of this, Celestica.
Right. Celestica is the final piece of the puzzle.
Because printing the chip is only half the battle. If these things run as intensively as our sources suggest, plugging millions of them into a standard server rack is going to literally melt the facility.
Yes, standard air cooling will not work.
So how is Celestica actually solving the physical integration at that massive scale?
So Celestica handles the physical reality of deployment. They are integrating these chips into circuit boards, designing the server racks, and most importantly, engineering the cooling systems.
The cooling systems.
Because when you have a reticle-sized chip running near maximum capacity, air cooling is no longer viable. The air physically cannot carry the heat away fast enough.
Wow. So what do?
You have to design intricate direct-to-chip liquid cooling manifolds, literally pumping coolant directly over the silicon just to keep it from destroying itself.
Pumping liquid directly over the chips, that's intense.
Very intense.
And this isn't just theoretical vaporware either. We aren't talking about blueprints sitting in a lab. The sources say they have already handed over the first engineering samples to Sam Altman and Greg Brockman.
Yeah, and our sources explicitly note these aren't just buggy prototypes either.
Right. They are actively running production workloads right now ahead of the massive deployment slated for late 2026.
They are actually running advanced models like GPT 5.3 Codex Spark on these engineering samples today.
Codex Spark. That sounds like a heavy programming-focused model.
Very heavy.
So they aren't just testing Jalapeño on basic chat prompts, like writing a haiku. They are running intense multi-step coding and reasoning workloads on it to really stress test the thermal limits and memory bandwidth.
Exactly. And if we connect this to the bigger picture, we really have to move from the scale of a single chip to the scale of global infrastructure.
Right. Let's zoom out.
Because OpenAI's ultimate plan isn't to just upgrade a few server closets. They are planning to deploy Jalapeño in gigawatt-scale data centers.
Okay, let's ground that number for a second for everyone listening. A gigawatt is 1 billion watts.
It's a staggering amount of power.
That is roughly the total power output of a large nuclear reactor, or enough electricity to power hundreds of thousands of homes. We're talking about data centers that consume energy on the scale of entire countries.
Right. And the environmental impact of training and running these massive models is one of the most pressing existential challenges for the whole industry right now.
Because as AI gets integrated into literally every piece of software we use, the energy drain is becoming completely unsustainable.
Exactly. So Jalapeño's focus on maximizing performance per watt isn't just like a clever way to save money on the electric bill.
It is a mandatory requirement for sustainability.
It is mandatory. If we rely on the old, inefficient all-terrain vehicles to power this revolution, we simply will not have enough electricity on the power grid to turn the servers on.
So it is as much a power infrastructure project as it is a computing project.
Oh, 100%.
Yeah.
And it is also driving a major geopolitical shift.
Yes. Let's talk about that.
Yeah.
Because by designing their own silicon, OpenAI is transforming into what the industry calls a full-stack infrastructure company.
Right. They control the entire ecosystem now.
From the software model you type your prompt into, all the way down to the physical microscopic pathways on the silicon running it. They aren't renting the kitchen anymore. They own the entire restaurant.
Which is huge because for the last several years, the entire AI boom has been bottlenecked by an absolute reliance on general GPU providers.
If you couldn't secure an allocation of their hardware, you just could not compete.
You're dead in the water. But by designing custom silicon, OpenAI breaks that absolute dependency.
And it also mitigates massive geopolitical risks. I mean, the production of advanced semiconductors is highly concentrated in Asian supply chains, particularly in Taiwan.
Very concentrated.
Any geopolitical disruption there could instantly stall the global tech sector. So by co-designing with companies like Broadcom and investing in a diversified manufacturing pipeline, the U.S. technology sector is attempting to secure its own physical foundation for the future of AI.
It's a massive power play.
So what does this all mean? When you strip away the gigawatts, the photolithography, and the supply chain logistics, what does Jalapeño actually mean for you, the listener, interacting with this technology every single day?
Well, it means the era of AI acting as this clunky, expensive tool that you have to explicitly open up and ask for, that era is ending.
Right. This hardware revolution is what allows future AI agents to become truly ubiquitous.
Yeah, because think about it. If the cost of inference drops by 50% and the energy required plummets, AI no longer has to sit idly waiting for a prompt.
It becomes affordable enough for companies to offer assistants that are constantly running in the background of your operating system.
Right. They can be instantly responsive, continuously analyzing data, and always available without just bankrupting the companies providing the service.
So the constraint is no longer the astronomical cost of the hardware. The constraint just becomes what you can imagine doing with the intelligence.
Exactly. It completely democratizes access to highly advanced, complex models that would otherwise be just way too expensive to run for everyday tasks.
It feels like we are witnessing the maturation of the AI industry. We are leaving the experimental phase of using whatever hardware happened to be available and entering the bespoke phase of engineering the exact physical tools required for the job.
Yeah, that's exactly what's happening.
So Jalapeño isn't just a new piece of hardware. It is a massive strategic leap. By creating a domain-specific architecture explicitly for inference, OpenAI is slashing their operational costs. They're pushing the absolute limits of energy efficiency to make gigawatt-scale data centers viable, and actively shifting the balance of power away from a hardware monopoly.
They are basically ensuring they have the physical infrastructure to support the next generation of digital intelligence.
But before we wrap up this deep dive, there's one final, totally mind-bending concept we have to consider.
Oh, I know where you're going with this.
It builds directly on the fact that OpenAI used its current AI to help design the Jalapeño chip in a record-breaking 9 months.
Right, that reinforcement learning loop we discussed earlier.
Yes. So once Jalapeño is fully deployed at gigawatt scale across all their data centers, OpenAI is going to have vastly more efficient, much faster, and more capable AI running on those new chips.
Right.
Yep. So what happens when they use that upgraded Jalapeño-powered AI to design the next generation of chips?
The cycle of innovation just begins to compound on itself.
Exactly. The hardware accelerates the software, which then engineers better hardware.
It's incredible.
How fast does that development cycle become? I mean, if the first iteration took 9 months, does the second iteration take 9 weeks?
Or 9 days.
Right, and the one after that. As AI begins accelerating the design of its own physical brains, where does that feedback loop actually end?
That is the million-dollar question.
It really is. So next time you type a simple prompt into an AI and get that instantaneous magical response, just remember the immense gigawatt-scale, custom-printed physical reality operating silently behind the scenes to make it happen. Thank you so much for joining us on this deep dive.
Thanks for having me.
Stay curious and keep questioning the physical foundations of the digital world around you. We'll see you next time.